Hello, and welcome to the second in our three-part webinar series on living walls. The first session was an introductory session. If you missed it or want to revisit it, then the recordings, as per all other Biotecture webinars, is available on our website. And the final webinar in this series will look at opportunities for vertical green infrastructure to enhance and enrich public realm spaces. But in this session today, we're going to focus on green walls as living cladding for buildings, mostly new build, but can equally be applicable to retrofit. I've got a lot to get through today, so I'm going to show lots of nice pictures as I go through it, but I'm going to rattle on through. I'm sure there's going to be lots of questions that we can answer at the end. And as always, if you've got specific projects you want to talk about, we'd love to talk to you about how we can help to design green infrastructure to suit your client's requirements. So a quick introduction. Firstly, my name is Richard Sabin, and I'm passionate about putting plants in, on and around buildings and transforming environments. I co-founded BioPanel in 2007, and I've been transforming environments ever since. And then just a quick reminder of what green infrastructure is. I went into this in the first webinar in a lot more detail, but in terms of green infrastructure, as far as we're concerned at BioPanel, it's about coming into the ultra urban zone, a place where space is at a premium, both literally and financially. And so green infrastructure makes a lot of sense when it's clinging to the side of buildings. But we also looked last time at green roofs and podium slabs, at pocket parks, internal greening. But what I'm going to talk about today, particularly, including some internal greening, is how we clad the vertical surfaces, particularly vertical surfaces of buildings as building cladding. And why green infrastructure? Well, again, as I went into in the first webinar, the holistic reasons why we need to include green infrastructure as sustainable parts of our cities going into the future. And what green infrastructure can do as cladding for buildings is just multifunctional, going right away across from planetary reasons right through to people, well-being, etc., and into those business reasons in terms of returns on investment. So what we need to do when we start to talk about the holistic things that we can do with building cladding systems is to start to think about why is it that we want to do it and what is it that we can do. And I believe that to carry out a piece of green infrastructure as part of a building, we need to have a client and they need to be a champion. They need to desire or want to do it for a number of reasons. And before we start to think about the 7 things that we need to consider when we're looking at green infrastructure, and that will be the sort of crux of this webinar, is the 7 things we need to consider. Let's have a quick look at some of the drivers, because these may be at play, and we want to start thinking about how our specification can match the vision or the intent of the client. So as I've shown in the first webinar and very briefly in the 2 previous slides, green infrastructure carries off a multiple of aspects in terms of holistic performance and holistic results that we can give to buildings. But one of the things we should definitely be looking to do is to cover off the reasons why the client, the person paying the money, wants the green wall in the first place. There are a number of things that clients are wanting these days, and I think it really fits into 2 camps, which are very interlinked in my opinion. And I'm going to talk about mitigation and I'm going to talk about enrichment. So in terms of mitigation, for me, this is about where we are seeking to make things less worse. When we talk about net zero carbon strategy, we're talking about making the world a less worse place rather than necessarily a better place. So that could be argued the other way around. And there's a number of factors that are at play here that try and drive us towards this. The urban greening factor is about increasing the amount of green space that's in there. I don't believe that it increases it enough or sufficiently for the enrichment that we could get, but the urban greening factor is there. And sometimes our clients' requirements are, can we satisfy biodiversity net gain requirements? All the while, we as a passionate green infrastructure company recognise the ability for us to deliver sustainability by stealth in these instances as well. So there's all the other aspects that come at play. But it's really important to understand what the clients want to do, the reasons why the client wants to have that green infrastructure. And so from an enrichment point of view, we have all of these aspects that are coming in, and post-pandemic particularly, some of the aspects of staff well-being, engaging with local community and encouraging people to come back into our ultra-urban zones are real reasons why green infrastructure is at play now in many of the environments within our cities. And just as a sort of highlight on the last fact that I just put across, we commissioned a survey back in January. There's a particular Monday in January that's called Blue Monday. Apparently it's when we as a country are our most depressed, and we wanted to turn Blue Monday green. So we wanted to understand what people thought about having plants in their cities, and we were really encouraged to see that so many people wanted more plants in the cities. And the ultimate fact that 78% of people say greenery improves their mental well-being actually should be a real factor at play in terms of what we do. So it's a very sophisticated conversation about what clients want and how we can deliver green infrastructure to suit their values. But I think it's really important that whatever we do deliver does tick the boxes that they would like to be ticked, as well as providing all the other benefits too. So when we come to consider specifying green walls, we think at BioTecture there are 7 things that need to be considered when we're starting to specify green walls. And I'm going to run through these in turn. So I'm going to talk about them in a bit more detail, but what we're looking for here is best value. So I'm coming back again to what does the client want? What values is the client looking for? And what other values can we bring because we're offering a holistic solution? Are we working with a proven system? Are we working with something that we know is going to deliver that value into the long term? And how can we work with that? Compliance is really important. The structural compliance requirements such as the CWCT tests, but I'll also go touch on the reaction to fire considerations that change depending on the environment in which we're in, and making sure that we've got the right system to suit the right compliance requirements. In terms of intelligent irrigation, this is about supporting the green infrastructure. As I'll talk about in a little bit, we're dealing with non-natural situations of thin substrates growing vertically. We need to make sure that we have really intelligent irrigation systems to support the life that we're trying to seek to put on the outside of the buildings. The next two kind of go together a little bit. Suitable light levels can often be a situation internally, and sometimes if you've got high levels of overshading, but really the suitable light levels go with the appropriate plants. So there are plants that can deal with lower light levels, and there aren't plants that can deal with complete darkness. We can provide artificial lighting, but for us at BioTecture, we're not very keen, particularly externally, on artificial lighting, because we think there must be situations in which we can use natural light, and we kind of want to try and move away from artificial lighting externally where we can. Internally, it makes perfect sense, and there's some very, very good LED solutions, particularly in non-light situations. And then the 7th thing to consider is robust maintenance. We really need to be considering that a green wall needs to survive and thrive and provide its benefits for a long time period, and that goes beyond just construction into maintenance. So really, I'm talking here about access for maintenance, and I'm talking about a commitment to a maintenance strategy. And we're also talking, hopefully, again, as I said in the first introductory webinar, about converting our thinking around green walls and green infrastructure in the long term from being a liability to being an asset. So rather than a liability to be maintained, we're now thinking about an asset to be nurtured because of the values that it's bringing to us. So when we start to go into each of these in turn, we start to think about best value. One of the ways in which we feel that we work best in providing best value is through our experience. We know where the best locations are to install green infrastructure to cover off whatever it is that the client is seeking to do. Is it well-being? Is it biodiversity net gain? Is it air pollution reduction? If, for example, it's air pollution reduction, do we need to be thinking about prevailing winds and where we should be installing a piece of green infrastructure to give that maximum value? If it's biodiversity, are we thinking about which flora we are installing to encourage fauna to come into that situation? So one of the things that we've done at BioTecture, and we know that the earlier stage involvement that we have, so the earlier we get involved in a project, we feel we can demonstrably add more value, is a green infrastructure index, where we're looking at all these features of the impacts on people, the impacts on staff, on customers, but also environmental impacts such as air pollution reduction, biodiversity, etc. And we can score and rate all of these on different green infrastructure intervention measures, and then come up with an objective table of which measures we feel are going to give the best value. This can have a real impact on allowing decision makers to release funding based on performance, anticipated performance of what's going to happen. So we know that the heart of what we do, everybody loves green infrastructure, everybody loves being around nature. How can we quantify that? And the question that we've been trying to answer for 16 years and still haven't answered fully is, what does a green wall do? And I think it's really important that we start to move towards that question. So early stage involvement can really help to add that sort of best value. When we come on to proven systems, at BioTecture, we have a number of different vertical greening solutions. Today, I'm going to be focusing on the BioPanel. The BioPanel is our flagship system, developed over 15 years ago now, and it's specifically for the cladding of buildings and structures. The other systems that I'm going to speak about more in the last webinar, which is about enhancing and enriching public realm spaces. So the focus today is going to be on the BioPanel living wall system. As I say, it's our flagship system. It's a living cladding system. It's added to the outside of the buildings, and it has been third-party assessed to be a range screen cladding system. Therefore, it can just be a simple cladding system as an extra material, or it can be the range screen cladding element of a building deliberately designed in to replace another range screen cladding system, whatever that might be, albeit that this one has an irrigation system and is living. And as such, it's therefore a replacement material and a replacement cost. And this is the case in the image on screen, which is a 2,000 square metre plus project at MacArthur Glens Outlet in Ashford in Kent, where the green wall is the range screen cladding element of the building. Not only is it fluffy stuff on the outside of the building, it is also stopping the rain ingress into the ventilated cavity zone as well. And just a reminder that we work externally. Projects here we have in go from top left across and then down. We've got Canary Wharf, we have Swansea University, Lord's Cricket Ground, another vision of Ashford Designer Outlet, and then 20 Fenchurch Street, the Sky Garden down the bottom left, installed in 2014. That's an image from this year, so showing how robust that is. And in each instance here, the green walls are range screen cladding systems. The BioPanel system also works internally as well, and as such, we have office spaces. The top and bottom ones on the left-hand side is Centrica's offices, one in Oxford, one in Windsor. You have legal and general top centre, you have a shopping centre, and then you have retail, and you have an office space as well. So lots of different environments in which we can introduce a cladding system, whether it's internally or externally. Externally is where we start to think about it as being a range screen cladding system, potentially as well. So some details of the system here. This is the BioPanel system on the screen here, and just looking through the system, I'm going to talk about each of these elements in turn. In terms of the support system, I will come back to that in a second. But the first part of the system, as far as we're concerned, is a waterproof backing board. This is a 12mm cement particle board, where the cement particle board is fully FSC certified in terms of the wood chip that's there. We then have a drainage geotextile, an aluminium rail that supports the irrigation system. The aluminium rail is from fully 100% recycled aluminium. And then a cladding panel, which is this panel here, panel shell material, 100% recycled polypropylene. And at the core of the BioPanel system is the Grodan growing medium. It's a hydroponic growing medium. And I want to just take a little bit of time just to talk through why we use a hydroponic growing medium and how brilliant it is and how it makes it so resilient and predictable in terms of the long-term performance of our living walls. So why hydroponics? There's often a saying that says it's natural to grow in soil. And it's absolutely true. In most horizontal conditions, it is natural to grow in soil, but it's unnatural to grow in thin substrates. Thin substrates like in commercial greenhouses where tomatoes, cucumbers, etc., a lot of the soft fruits are grown. It's even more unnatural to grow in vertical thin substrates where the inputs of rain, of dead and decaying matter to make humus, of connections with the subsoil, the endless movement of earthworms coming in and out that you would get in a fantastic horizontal landscape don't exist in a thin vertical substrate. And the deficiencies of soil in those situations where it's not getting those inputs become a real issue over the longer term. The pioneer of green walls, this visionary guy, Patrick Blanc. Those of you who've not heard of Patrick Blanc, he's worth looking up. His projects are extraordinary the world over. Patrick is a botanist, and in the mid-1990s, he really started the modern movement of living walls. And he really is a complete visionary. The first thing Patrick does when he works with his plants is he washes all of the soil off the plants. So he's just bare rooting all of the plants. He then so he recognises the deficiencies that soil has. He then takes the plants with the bare roots and then does something that we don't do, which is he has 2 3 millimeter thick layers of felt. He cuts a slit in the first layer of felt and pops the plant in and then staples that plant into position. Not a hugely robust system. And then his plant choice, because he's a botanist, sometimes at the top of his living walls, he'll put buddleia, for example, which in the wind could become, in our opinion, spears that may come down and have a health and safety issue below. So what we've done is we've taken Patrick Blanc's system and we've taken the idea of hydroponics, and we now work with a substance called Grodan. Grodan is an extraordinary material developed over 50 years ago now, as a deliberately engineered substrate for working in thin substrates. It's a 1.8 billion euro business worldwide. Every tomato you buy in a supermarket is grown in Grodan. That's almost guaranteed. And the reason is because it's dimensionally stable, it's chemically inert, it's supremely water efficient, and that creates the perfect root zone for plants. And it does that because it's chemically inert. It will do that over a long period. There are a bunch of sustainability advantages to Grodan as well, because it is it's basalt rock that's basically been spun and blown. So it really is the prime constituent of soil anyway. It's rock. It's just been accelerated in terms of how it's kind of been weathered, and accelerated weathering of basalt is a proven absorber of CO2 as well. And so from a sustainability point of view, it's really strong too. So this is why we use this material. If we felt soil was a better material, if we felt there was another hydroponic material to use, we would. But we work with the proven thin substrate material that's been designed and engineered specifically for the purposes for which commercial growers use it, and for what we do in terms of growing on the side of the buildings. So when we house it into our systems, we put 4 strips of Grodan into a panel, and then we have irrigation at each layer. And the reason we have irrigation at each layer is the panels are solid at the bottom, but open at the back to this drainage shear textile. So as the water drops down through the Grodan, reaching 80% water content, then it drips into the next layer, the next layer, the next layer, always offering that water and the nutrients that are added out to the plants. The water then hits the bottom and comes out and comes back down in the drainage geotextile layer. This means that the water from one panel is not dropping into the next panel and not dropping into the panel below. The reason we do this is it allows us to control the water content or moisture content across the whole of a living wall. It also allows us to control the nutrient content across the whole of the living wall. It's unique to BioTecture. It's our patent, and the problem with having water aggregating down a living wall with nutrients is if you add X nutrients in one location and X plus 1 and X plus 2 and X plus 3, by the time you get to the lower sections of particularly taller living walls, it becomes very difficult to work through the chemical balance that might be in the nutrient system, and you can get nutrient lockout happening in those situations as well. So we're a very controlled system where we're controlling the water content across the whole of the wall, and it's the lowest water use that's possible as well. So that's the system that we're talking about here in terms of BioPanel. So what we want to talk about now is living wall design, and these really are some of the factors that we need to consider. The first thing we want to look at when we look at living wall design is the panel layout. So each of our panels is nominally 600 millimeters by 450 millimeters, and when it's fully saturated, each panel weighs about 15 kilograms. So it's manhandled by one person. And on this panel layout drawing here, I've got a perfectly oriented and aligned area where 600 by 450 panels perfectly fits into all the spaces, even with the doors and the windows. Now, not everything comes as standard. So what we can do is we cut the panels down so that they can be smaller in height, so that it can be smaller in width, and they can then fit into and around any dimension that we want to fit into around. We can also work with curves and with corners as well. So working around curves with different radii means that we're starting to look at having thinner panel sections that articulate around the curves. And whilst the panels are faceted, the plants don't follow the facet, they just follow a curve as they follow around. And the same with the corner panels. We can pre-grow these corner panels in our nursery. They come to site and up they go. So that's great. So as we look at this new way of 10 years ago, new way of vertically cladding buildings, we started to work with some independent structural engineers for an assessment of the system. We wanted to make sure that even though we're putting fluffy stuff on the outside of a building, that we are being fully compliant with all the requirements of any other cladding system that's being put onto buildings. At the start, when green walls were first being put onto buildings, even building control used to ignore green walls. They would say it's landscaping, it's nothing to do with us as building control. Thankfully, that situation is now over, because it's, we are putting cladding on the outside of buildings, and we need to make sure that we conform. So we underwent a thorough structural engineering assessment with a third-party structural engineer who came up with a number of recommendations. They carried out destructive testing on every part of our system to enable us to come up with set standard details that would work in standard situations, but also in more exposed situations too. And one of the things that we did as part of this process of making sure that we were being compliant was we fully underwent the CWCT testing. We tested here for wind resistance up to 140 miles an hour, water tightness in terms of any range screen cladding system needs to deal with water tightness, and impact resistance. I'm really pleased to say that the BioPanel system passes all of those tests for CWC compliance, and therefore is a CWC compliant test, CWC compliant cladding system. Both working with Evolve and working towards CWCT enabled us to develop our standard details. They're available through the website. They're also available through MBS Source and through Specified By. But essentially what we're looking at with support details for the living walls is to have some cladding rails at 600 millimeter centers that are capable of supporting 75 kilograms per square meter. Now those rails can be horizontal, they can be vertical. They don't need to be both, they can be one or the other. So rails at 600 centers, horizontally or vertically, to support the backing board. And then everything in front of the backing board, the aluminium rail, the irrigation, the panels, is all supported from the backing board. So the initial support is to the backing board, and then everything supports off of that backing board. And just to blow out some of the detail that's in there, we have worked with the manufacturers of the board and worked with evolved structural engineers to understand the right detail that we need to have for our fixing in terms of how close to the edge we should be fixing. This then dictates the size of rail or size of board or whatever it is we're fixing back to, that we need to be using. And in terms of the support system, I've put four standard type systems down here. There are instances where the timber cladding rails make sense, and we've worked on a number of timber frame buildings, one of which we re-inspected after 5 years of being installed, and it showed no signs of degradation. But our standard fix when we're fixing as part of a cladding system to buildings is to use a metal system, whether that's a simple Omega top hat or whether it's a helping hand system or whether we go for a bespoke steel frame. And I'm going to show you a couple of an example of each one of those. So when we look at the Omega top hat, in this instance, this is not a range screen cladding. This is a student accommodation block in Coventry, and there's a completed brickwork building or block work, as you can see behind where the actual living wall is. And we have the Omega top hat rails which perform the separation. It's an attachment to the building in this instance, and gives a 25 mil separation from the building. When we start to look at a helping hand situation, we can start to think about ventilated cavities. We can start to think about how we could be putting insulation within this cavity space as well, which is actually what happened on this project. This is a 75th floor of the Pinnacle building in Canary Wharf. And helping hand brackets with the thermal isolation breaks, you can go all the way from 40 mil up to 400 mil. Typical for us would be in the sort of 100 to 200 range, but we can work on all of these ranges in terms of how far forward or back the living wall wants to sit. And often that's a consideration in relation to other building elements. Do the panels want to sit flush with the rest of the cladding of the building? Do they sit recessed so the planting can come out and appear to be in line with the cladding? And these are all considerations we can look at in terms of how these things work. So that's Omega top hat and helping hand brackets. And then there's a bespoke steel frame, which is demonstrated by this car park we worked on in Coventry of 700 square meters of living wall, acting as the front facade of this car park. And an independent steel frame restrained back to the car park structure was the chosen building method here. And you can see top left the frame, and then top right the backing board going on, and then we have the insulate, the irrigation and drainage geotextile here, with the planting starting to go on, and then the completed planting as well. So that's kind of how we fix it from behind. When we start to talk about the green wall itself, it's always the interfaces that are interesting from a design point of view. The centre of a green wall is kind of as we've shown it. You have panels, you have plants. Great, there's nothing really much to talk about there, but we need to talk about the top, the bottom, and the sides. So from the top detail, which is detail A on screen here, as a minimum, we're looking to stop light and heat from acting on the irrigation line and on the top of the growing medium. Plant roots do not like light, so the plant that's at the top of that living wall most definitely wants to be shaded or covered or in the dark, and this is the requirement for that cladding there. Here's a slightly more sophisticated example of that cladding, where we have, and this is again the Cannon Park students accommodation block area, where you have a more detailed sort of feature that's acting both as the way of shading or completely making dark the growing medium zone in this irrigation pipe here, but also acts as a architectural feature that sits out and around there. And that works really well. Then looking at bottom detail B, which is the bottom of a living wall, we need to have somewhere for the excess water to go. Living walls are biological systems, and like us, we're biological systems, they need a waste. They need a way to get rid of excess nutrients, excess water. We aim for about 10% of what we put onto the top of a living wall to come off in drainage at the bottom. And if we get that sort of balance, then we know that we're flushing the grey medium through all the time and making the perfect environment for the plants. Ideally, this drainage will go through to an area of soft landscaping. So if the bottom of the living wall is at ground level and there's a soft landscaped area here, you can simply drop it straight into soft landscaping. If it's got any height to it, then we probably need to collect that water in a gutter type system. And we have an example here of almost both really, being collected in a gutter type system and then being taken to a planter, and then there's an overflow from the planter. So what we're looking at is using the excess irrigation from the living wall to then water some soft landscaping that's in a planter. And this is again at 75 Pinnacle. So if you have a look at the downpipe there, you can see it again in a completed situation here where we've got just lovely green wall overlooking half of London and half of the south of England, to be honest. And the excess water from there is then irrigating into the trough spaces in here. And then when we think about the sides of a green wall, so left and right, we're starting to think about how do we get the irrigation lines up to the panels, to irrigate the panels. And so this is a plan view showing a couple of irrigation lines. This one might be coming off here. This one might be going up another 10 meters higher and then watering in to the next levels up. And at the far end, we also have some flushing zones. So the ability for us to take this cap off and flush out any water that comes in. And we're flushing out the water, but we're also flushing out any of the detritus that may have formed inside the irrigation pipe. Typically, this can be calcium. So calcium deposits can typically form, and they can start to clog up the very sophisticated pressure compensated drippers. So once a year, once every 2 years, depending on location and depending on water quality, we'll want to have access to here to flush these out. And so what we have is, what we'll need is these little riser ends that are covered off. So an example here from the Ashford Designer Outlet is showing the cover of the irrigation risers here. And the dotted line is the side flashings, which is by others. Now the side flashing on the photograph becomes the gunmetal grey trim that goes around here. So this isn't removable. What we've done is just inside of here, we've used a small thinner piece that is removable to allow us access back into there. So designing for these openings is something that we want to be able to look at and work on, and make sure that the irrigation is accessible, but also that we're not taking away from the architectural features that the architect will want to include within the building surround. And again, when we're talking about windows and doors, it's very similar detail where the sill of a window is pretty similar to the top of a green wall, where we want to make sure that the grey medium is covered up and in the dark, and that the irrigation tubing is also covered up. We want to make sure that at the head of the window we've got a gutter that's collecting that water, so we don't have water dripping down here. And the side and jambs are the same detail as the side details. The only one that's interesting really on this one, or different to the others, is the window head detail. And a lot of it depends on how much living wall there is above that window head detail. If there's a lot of living wall, then we need to be making sure that we're picking this up in a gutter and delivering it down, possibly in the jambs of the window, in a downpipe, in a small downpipe situation. If there isn't huge amounts, like in this example here, where there's only 4 panels above, we'll often drop the excess water into the panels on either side and allow them to deal with that locally. Sometimes we'll deliver it down to the green wall, we'll deliver it down through the jambs to the green wall at the next level down. So there are different ways of dealing with window head details, often depending on how big that opening is. An example I'll come back to later because I'm going to run through a case study right at the end. This is a retrofit building, but it's a similar type of requirement for these flashings that go around the side that have this dual role of being the interface material to the next material, but also hiding the irrigation there as well. So we'll come back to that one in the case study. And the last area I want to talk about, so we've done top, middle, bottom, so in the top, sides and bottom, middle. So the middle element of it to us is about protrusions. Sometimes it's about signage. In this instance, a blade sign going through a project we just completed in just north of Paris. And what we're looking to do here is amend the panel design so that we can have signage coming through, so we can have lights coming through. You can see in this instance the base structure is concrete. Often it's not, it's a Metsec frame. Sometimes if the signage is light enough, we can deal with this in mattresses that just sit onto the green wall. We also look at CCTV cameras and other things that can protrude through. And there's also the opportunity for signage to be in the green wall as well. So there's a whole bunch of things that we can do within the green wall. So that looks at design and that looks at some of the aspects of that. And if you have any specific projects, we'd welcome the opportunity to work with you on each of these designs, top, bottom, sides, protrusions. I'm very happy to look at details at early stages just to see what's practical. So I'm going to go into another compliance issue. We've talked about the compliance issue from a structural aspect. We've looked at CWCT cladding performance, but it's also really important to cover off the reaction to fire performance. But the BioPanel has undergone a full engineering assessments with regards to reaction to fire. As a living cladding system, BioPanel, like every other living wall system, is what's called a non-conventional material from a reaction to fire point of view, and therefore it's not possible to get a fire certificate against the system, which is really unhelpful actually, but for a number of reasons. But to receive a fire certificate, a cladding material must be tested in a smooth and dry condition. Hopefully a living wall is neither smooth nor dry, and therefore it can't meet the initial conditions required for fire certification. So the only route to performance is through engineering assessments. And so we've undergone a full engineering assessment with regards to reaction to fire. And this looks at operational conditions. It looks at all sorts of aspects of it. And I'm sure there are going to be some questions that come out of this one, either at the end of this webinar or take them offline and come and talk to us. But we've gone into this issue in great detail. As part of the industry, we've got together, because it's so important, and produced a document which we consider to be our best practice guide document about living walls and fire safety with regards to external cladding. This isn't about public realm spaces, this is about the external cladding of buildings. There's the approved document B, which is the update on the building regulations with regards to fire safety. In June 2022, really clarified a whole number of things around building types and building purpose groups, and which building types could be worked on with non-combustible materials and which building types could be worked on with combustible materials. As it sits with the living wall, because they've got plants and organic matter, they will burn, but how much they burn is really important. And the operational condition engineering assessment report confirms a type B, which is the least combustible category that's possible. And the approved document B in June 2022 really updated on which building purpose groups we could be using type B materials. And essentially what we're saying now, or what that document is saying, is that for any buildings over 11 meters that are residential, or buildings where anybody may sleep, can be non-combustible only. So anything over 11 meters is A-rated, not living walls, not possible. And we don't talk to clients about these situations, or when we do talk to the clients, we say, look, we don't believe that a living wall is right in this situation. Having said that, the situation is still so ambiguous that we have clients who are talking to building control about what measures we can take to include living walls in those situations. So that leaves us with non-residential buildings or residential buildings under 11 meters. And in those situations, we have 4 key recommendations that we include within our summary. One, that it's tested in accordance with that it's in the only systems that have been tested in accordance with whole system engineering assessments are included, that we only include materials that were part of that assessment, that we have an irrigation system that is designed, installed and operated in accordance with the best practice guidance, and that there's always a proactive maintenance contract in place. So I go back to this idea of a living wall being an asset rather than a liability, and having a proactive maintenance contract in place should be something that we want to be doing anyway, but it's one of our key guidance notes in our external cladding, living walls and fire safety best practice document. So I'm sure we'll come back to that, and I'm sure many of you will want to have conversations about that with us, and we'd be delighted to have those conversations. I can't say we have all the answers, but I think we have some good direction in terms of where this is going. So following compliance, we move on from that to intelligent irrigation. We have irrigation plant rooms that will be sited within projects that will then deliver water via solenoid valves to various locations. Each valve is selected, or each location is selected according to its local environmental conditions. So on this tall living wall in London that was installed in 2017, and again this is a photo from, I believe, September this year, so 6 years old, we're going to get more requirement for water at the top than we are at the bottom. And so these different zones will be calibrated so that they can deliver via remote sensed irrigation systems, with adding some nutrients in, more water at the top, a bit less in the middle, and a bit less at the bottom. And this is characteristic, and this is a northwest facing project. If we have a south facing project, then that's going to demand more water as well. Being intelligent means we can remotely control it and remotely sense it and monitor it as well. And this is a big key and a big driver in terms of the engineering assessment with regards to reaction to fire. The proving of operational condition is via the remote sensing of the irrigation system. We're able to hook it up with the BMS as well. This photograph, or these photographs, are from our office in West Sussex. This is where we are constantly monitoring, and we receive emails from the systems when they fall out of system parameters. So, you know, we have a really good track record of consistent monitoring of irrigation systems within the green walls. Moving into planting design, we need to work on client aspirations. So this is both in terms of the aesthetics, but also what else is it they want to do. We recognise at BioTecture that what we offer is a visual crop. We offer something that needs to look good, and people seeing it and well-being is really important. But what else are we looking to achieve? And often we're driven by clients on this one. In this instance, it's on the screen. On a couple of slides about this in a bit later. This is a project in Leeds where we're looking at the almost creating a vertical forest there with different bands and areas, and biodiversity was a huge driver in that situation. In this situation in Edgware Road, the driver and the funding came from clean air. So we are able to then test those species in terms of their ability to take particulate matter out of the air to deliver the value set that the client wanted to deliver. In this case, the client was Boris. And one thing Boris really correctly identified was that not only is it taking pollutants out of the air, it's also helping to soften and beautify the local environment. So these are the holistic things we're looking to achieve. And so as a business, we start to look at, from a light level point of view, where are we? And if we're south facing and we're external, we have a whole bunch of beautiful plants that we can use, lots of colour involved. When we go into the shady area, you can kind of see that it's dark darkened off a bit. It's got a bit greener. We've still got the ability to deliver some colour, but plants depend on light, and the less light you give them, the less colour they can give you. And then we come into partial shade. We've kind of got a nice mix of them both. What we tend to do is we tend to work with our clients to see what sort of designs we can put together. So this was an interesting project in Coventry. This was a car park very near the student accommodation blocks we saw earlier, working with Parkhood Landscape Architects to really sort of play with a design that sort of dances across the living wall. Coming back to that project in Leeds, huge living wall, 130 linear meters, goes up to 28 meters high. And we're looking at mimicking the North York moors here with more sort of grassy woodland type at the bottom and then a bit more moorsy at the top. And then detailing the plants that have been included in that. Within this one, we've done something we really, really enjoy and want to repeat, which is we have deciduous plants like dogwood that in the winter will show their colours, but they may show some gaps as well. But for biodiversity, this is fantastic because it's offering really good locations and places and spaces. So, you know, you've got this design of this upland moorland, or trying to replicate that. And I think we've done that really, really well with, you know, these more bushy species down the bottom and a bit more moorland. And then kind of as you come up to the top, you're really sort of mimicking what's happening in the North York moors there. And that example is a really good example to talk about biodiversity as well. So we can encourage biodiversity by putting in biodiversity habitat boxes, bug hotels. That project in Leeds has almost 750 habitat boxes nestled within some larger shrubs, etc. We're looking at, we want to look out for solitary bees. We want to provide food stations for birds and bats. So in here we've got ladybirds, lacewings, centipedes, millipedes, small invertebrates that then the green wall then becomes food stations for birds and bats. So that's looking at the design. So once the design is done, I think it's really important to have a quick run through what happens next, because there's some aspects here that should really circle back into design considerations. For example, designing for access for maintenance is really important to think of at the design stage. The first thing we do once we have the design and once we have a plant design agreed is to pre-grow those plants in our nursery. And this is an example here of some plants being pre-grown. You can see that Campbell in the yellow vest there is our lead horticulturalist. And to be able to look after these plants at head height, or Campbell's quite small to be fair, so just above Campbell's head height, is much easier than sending them out very juvenile into aggressive situations, maybe 30 meters up in the air, and then expecting the plants to have good root zones. So there's two reasons why we grow in the nursery. One is to get good root growth, and the second one is because there isn't a second chance to make a first impression. And then from horticulture, we come on to construction, where we go through the whole process of carrying out the health and safety documentation, etc., etc. And then we have, with the BioPanel, we have a two process installation. The first process is that we are putting in all of the backing structure. We're putting in all of the supporting rail system, the drainage geotextile, and the irrigation. And we're able to fully test and commission the irrigation system before any of the panels leave site. So I think that's a really important point for us, is to make sure that everything's working and everything's hunky-dory before the panels leave site. So that's the first fix. The second fix, I'm going to show you a quick video. It's just a minute long. And the second fix is of the planted panels themselves arriving at site and then going up onto the building. The means of access is interesting. On very tall buildings, we're looking at scissor lift type mutes, or in this instance, mast climbers. We used to have the minute waltz music to accompany this, but it seems to have disappeared, so I'm having to do a talk over. But as you can see, it's very quick to install, and the fact that we've pre-grown it in the nursery means the first impression for the client, for those walking past, isn't of a pixelated living wall. It's of a healthy, because the root structure is already grown in, living wall that's already got 80–90% coverage. And this is what we aim for when we deliver living walls out to site. Then moving on into maintenance, which is something that we really do need to consider when we are going through the design process. Often the construction means of access is fairly well covered off because there are other materials that are being installed. But when we come to maintenance, the green walls generally need more maintenance than the other building facade elements. We have it very well honed down in maintenance. We're looking at 2, 3 or 4 horticultural visits a year. North facing living walls 2, south facing living walls 4 is a rule of thumb. It doesn't necessarily mean that's the way it is, but that's kind of a good rule of thumb. And this is our maintenance strategy at BioTecture. We look to inform with a plan of works, and we're looking for ecological progression. We're looking for long-term growth across that living wall, and we're looking at the sustainability of the whole wall, not just individual plants. The way the panel system works allows root migration to happen across the whole of the wall. It also allows migration of the plants at surface level because it's not, each of the plants isn't held in an individual cell. We're able to migrate plants across the surface, and so what we get is close knit living walls that we're able to really maintain without huge numbers of plant replacements, because we're allowing that ecological progression to come through. So we anticipate 3% to 5% plant replacements per year on that living wall. But we also plant at 60 plants per square metre and expect that during that ecological progression, that number will actually drop to 50, 40, as the living wall becomes really so comfortable in its surroundings and comfortable in its space. And so, yeah, that for us is really important, how we look at maintenance. But we do need to go and visit those living walls probably 2, 3 or 4 times a year, and how we do that needs to be covered off at the design stage. Different means of access, whether that's through scaffold towers or MEWPs or BMUs or even abseiling. So I'm just going to, with a quick case study to conclude, I'm just going to kind of pull it all together and really quickly run through all of those elements of a project we installed in 2016 and we still maintain now. This is in Southampton Row in Holborn. It's a retrofit. Here's the existing building, but the solutions here equally apply to new build. It's just a case that in this instance, it's not a range screen cladding. It's an attachment to the building. The drivers for the client. So what did they want? What they wanted, they're an environmental business, so they wanted to be seen to be green. But they also recognise that Southampton Row is one of the busiest bus routes in London, so air pollution reduction is really important, as was biodiversity at the top. So they wanted some air pollution reduction plants and some biodiversity plants. So we produce CGIs. CGIs are something that, because of what we do is so visual, CGIs are something that we can produce to help to explain or talk or sway or inspire clients into the idea of green infrastructure and what we can do. And I'll come back to the planting in just a sec. Structural fixing. So we dealt with the structural fixing in terms of how do we do that in other instances. In this instance, we've got a bespoke steel frame that we're trying to put through. We did a structural analysis of the existing building that showed that the brickwork that was on there was purely a range screen cladding of its own, and so couldn't be fixed to. So the fix was to the main concrete behind, which then gives us a cladding rails that we're then fixing in very simply. To those cladding rails, we are then supporting the backing board. And so this is the basis of the system. This is what we want to do, is we want to get some rails here and we want to be able to support the system to the backing board level. Once we've got that at 75 kilograms per square metre, we're off. We can run, we can do what we need. Irrigation design. This is the intelligent irrigation design. These are the 4 zones. So I think in the cross section we saw 2 pipes going up. In this instance, there are 4 pipes going up. And one zone is feeding the bottom and one zone is feeding the very top, and you've got 2 in the middle, and the one that's feeding the top will be the one that we're going to want to turn on more often. And when we say more often, we mean probably in the middle of summer this one's going to be on 4 times a day for 3 minutes, whereas this one down here is going to be on 4 times a day for 1.5 or 2 minutes. So it's not hugely significant time, but that difference does make a difference in terms of the water content that's maintained within the building. From the planting design, we're looking at plants that were part of the air pollution reduction strategy that were discovered when we did the Edgware Road project. So we're really looking at air pollution reduction plants. And then at the top, we have the armeria and various other plants for pollinators as well. Grow the plants in the nursery for all the reasons that I've said before. And then the planting starting out on site there. And again, with the window detailing, this is what I showed earlier in terms of the windows and doors. How we're dealing with that flashing around those windows is bespoke to this particular project. And the final image of that project is something that has, the flashing around the outside. Architecturally, I think it looks great. And in terms of performance, not only is it taking away some of the air pollution from the buses, also behaving brilliantly from a biodiversity point of view at the top. We also put a thermal imaging camera onto this area, and you can see that the building next door is at 40 degrees while the green wall's at 22. So the thermal impact on the building is really important as well. And I think going forwards in terms of climate change, which is something I spoke about in the first introductory webinar, it's really important that we start to think about the thermal impact on our buildings and on our cities, and some of the added benefits that we can get from using green walls as cladding systems. What I would also like to see is some brise-soleils and natural brise-soleils where we're covering these window spaces with cables and wires and growing deciduous plants up here, so that in the summer we are really helping to ameliorate the temperatures that are coming into the windows, reducing the amount of air conditioning. But in winter, when those deciduous plants aren't there, you get the amount of full light that's coming through. So we can really use nature as cladding systems within the buildings of what we do. So that's basically a quick run through where we are with cladding systems. It's a 55-minute run through, and I've kind of raced through it. And I'd love to have any conversation with anybody offline if you've got any projects, etc. But Jess, I'm just wondering, are there any questions now? And I really appreciate it. It's very nearly 3 o'clock, so people may need to drop off, but I'm very happy to stay around and answer any questions if anybody's got any.